thank you everybody for still being around. This is the afternoon bracket. So I hope I'm going to make this very entertaining for you. So I'm going to need your input as well throughout the presentation. And let's go right into it. So my passion is definitely for equipment. So as you heard, I've built equipment, specifically assembly integration, so body-in-white welding lines. But these are also considered assets or heavy assets. So this is me and a little bit of my story. We're going to skip over that. We're going to first go through a little bit of a definition. So if heavy assets doesn't sound a bell to you, this is how I define it. So heavy assets is something that is typically very essential to a company, right? It can be a piece of equipment. It's usually also quite expensive. And in some of those companies, the heavy assets would be a piece of equipment that they have only one of. So if this goes down, the whole plant stops, right? So the two ones that I have interacted with is specifically machinery and large scale equipment, right? And of course, since it is a heavy investment as well, and there is some depreciation, those things need to be running for a company to make money. So you can see one example over there. Who has seen something like that in real life already? Okay, yeah. Big stamping press, right? Several thousand-ton press. And those usually are built by machine builders. We call them machine builders versus assembly lines are built by integrators. I have heard that name multiple times. So that's how we divide them up. Cool. So first, let's do a real quick check. So I'm going to let all three come up already. Who of you buys and sells equipment? Okay, good. Yes, perfect. So maybe 10%. Who buys equipment? Who are the purchasers? Oh, okay, cool. Well, we have a match here, right? So maybe 20% of the people. And who operates equipment or has like a manufacturing company? Okay, that's half of the room. Cool. So now I understand where this is going and what the audience is. It's going to help me also articulate throughout the rest of the presentation. I appreciate that. So when I 2014, right, back to that date, this whole thing started off maybe 2011 at the Hanover Fair. Everybody knows that story. And 2014, most of the stuff consolidated because the big firms, the big four, came up with their analysis of the impact that this new trend is going to have on the companies that they were consulting for, right? So I must say those guys back then did phenomenal work. And McKinsey specifically came out with a piece. Okay, that was back. McKinsey came out with a piece that looked like that. They call it the radar, right? So instead of putting the technologies in the center, they actually looked after the value and put the value drivers. That's what they call the segments in the center, in the center of the radar, and then put the levers. They call them the levers on the outside, and just after the levers, you can actually get to the technology, right? And there's multiple options to get there. But then they also identified the opportunity for typical manufacturers on the impact on the bottom line of their business, right? And all of the outside indicators, I can tell you, they looked crazy back then, right? Because we thought we were already optimized, but I can tell you some of them can even, what we have seen now, and this is 2017, some of them can be exceeded. Some of the opportunities even bigger than those guys visualized back then. So I'm in the tier one business. So with the presentation before with the GE guys, I could see that the GE guys that actually have the product at the consumer house, the appliances guys, and the factory connected, they can take the full circle, right? They can do supply demand match, time to market, they can do everything. In the tier one, we mostly do build to print. So we're automotive part supplier. So usually we don't get to control a portion of this. But what I've seen, what really is helping us and what's applicable to us at least, is the resources portion on the top, asset utilization, of course, and that's where my heavy asset portion comes in, labor and quality, right? On the rest ones, there's a limited potential, but this one is huge for us. So after that, let's go into the, shout out to McKinsey there. Let's get into the specific use cases I've seen and what can we actually calculate with the specific data that we collect. Because I've seen a lot of, we collect all this data on an equipment level, but what do you actually make out of it, right? So the specific use case that I've seen over the last 2 to 3 years is performance and status of the equipment. So what do you actually have to collect? Usually cycle time, error messages, part count. Where do you get that from? You usually get it from the equipment PLC itself. So this is nice, right? We don't have to wire anything new. We usually can tap into what's actually installed. And what do we calculate? Usually we do some cycle time analytics on a station level, OE, of course, and we can do then shift comparison and that kind of stuff. So performance and status is one use case, and some of the, it's not all of it, right? I can't give up everything here, but most of it you can understand yourself. The second one, I call it equipment health, right? Usually, the equipment manufacturers, they build in some sensors that should be able to indicate us what's the degradation of this equipment, what's the status of this equipment, right? And usually it's pressures, temperatures, forces, e-stops, etc. And what can we calculate out of that? Maintenance schedule, equipment degradation. And what's interesting is the manufacturers of that equipment are developing algorithms, right, to do that. But we have to connect the equipment to them, to their cloud to actually do it. And they're going to come to later back to this point, and I'm going to give some suggestions how we can actually do that. Third use case, and this is a use case that is very handy to build out your data pipelines, because none of your divisions, none of your plants, none of your areas in the plant is going to say, oh no, we don't use energy here, right? So everybody uses some kind of energy, and this is really great to build out the data pipeline. It's a great use case. Energy consumption, air, oil, gas, whatever you consume at an equipment level, it can even be raw material. You can then calculate a lot of things, and we are particularly interested in variable cost per unit or part, which is something that, of course, is very interesting for our business guys when we sell a new product, because still we are guessing it, right? So, of course, there is this green component to it, and potentially we can do a CO2 footprint and all that kind of stuff if the customer wants it. But the primary driver is cost reduction in energy, right? Because energy is, of course, expensive. And the third big use case is process and quality. So this is specific to the product, and this usually has to get added to the product information that we ship to the customer. Or if the customer doesn't want it at that point, they definitely want it if there is some kind of claim or warranty, right? They come back to us and we have to have that data. So very important. And this is, we call it a birth certificate if this is batch production, right? And we have to give it with the product to a database. So this is what I have seen. And how do we actually extract all that stuff? Well, shout out to the guys from HiveMQ. So I took that from them. And because it's really what's the state of the art, most scalable architecture that we have found. And we have applied this now to over 150 sites globally, and it scales. So in the center is what I call an on-premise real-time streaming, event streaming block. And Walker Reynolds and the team calls it the unified namespace. So basically he branded this and HiveMQ took it, which is fine. But at the end, what we call it is the on-premise, or what it is an on-premise. It sits at the plant, real-time event streaming broker, right? Now, what's interesting and what HiveMQ doesn't show is, if you look at the governments of what flows in there and how do you code all that stuff, to the left, you can go pretty low so that the people on the shop floor can actually do all that good stuff. And to the right, you have to be more restrictive on what actually flows and how that's built. So how does it look in reality? Something like that. So it's still a work in progress as well, so you can imagine that. Okay. So now that we have all those use cases, I have learned a lot about digital twins. So let's look at some of the newest and best video that we have done over the last couple of weeks about digital twin that we have built for a casting operation. Let's see how loud the audio comes in. So high pressure die casting, who does it? Who knows it? Oh yeah. So this high pressure die casting parts, and this is a 3D virtual representation, which is, as many of you already know, just the first step. But you can now see that we actually overlay that with real-time temperature that a thermal camera takes. So the maintenance engineers, process engineers, supervisors would not actually have to be physically near this equipment, which is, if you know it, kind of intense, let's say it like that, from a temperature and perspective. So this is our facility. Yeah, that's probably the cleanest you will ever see a casting facility. Maybe it's like 1 month after it's built, and then like it's only downhill from there. But yes, you know what I'm talking about. Cool. So this is the UK. What I've learned on use cases for the digital twin, real-time monitoring is huge, of course, right? You can actually visually see that on the equipment. Training for the technical team. Now imagine being able going into these cylinders that are usually you can't even access it, right? So they can actually train it or do some procedure before they actually get in on the weekend if production eventually shuts down. And then process simulation and parameter simulation. We call it also recipe simulation. It's huge. And of course, predictive maintenance. Okay, so talking about data, I came up with this idea of who produces the data. Besides who produces, who then owns that data, right? Who needs what data and who should potentially monetize it. And I think this is really what has held us up as an industry over the last 3 years, since many people have tapped into all of this data. This incentive issue has held us up. Why? Because we bring a big piece of equipment in. First of all, most of the data that is important to the machine manufacturer, we are not giving it to them, right? And less in real time, right? So this is the first one. The second one, we don't even know how to connect to them. And of course, the huge fear is that anybody would have our process data, right? So by understanding what I just showed with the different use cases and the different batch sizes and the different temporalities, you can actually split what is extremely valuable to the machine manufacturer with the MQTT protocol and what is exclusively important to you from a process side. Because what we have seen, for example, it's incredible what you can see on pure electricity consumption of a machine. You can see, of course, how many shifts it ran. If it's a press, you can see what die ran in this press. At the time, the curve looks different for every die, right? So if somebody only looks at energy data and knows what's going on, they can deduct a lot of information that potentially only you want to know, right? Only you don't want to give that out. But what we can do is we can aggregate a weeks of production, a weeks of torque, and give this back to the equipment manufacturer for them to learn and improve their equipment. Because I can tell you, I've built so much equipment, about 1,000, it must have 2,000 robots at this point in 150 projects over 15 years. I've built so much equipment, but I've not ran so much equipment myself. So so a lot of the information and of the behavior of the equipment only shows up during production, and not every manufacturer gets that chance. So also give the manufacturers some chance for them to improve their product, right? That's my core message there. And of course, if you look at software suppliers and all of the people that are in the ecosystem, now imagine if we don't give the software programmers the access to the data, they can't even build the product, right? So I hear it all the time. Oh, if we give them the data, then they're going to just build the product and sell it back to us. Well, and if we don't, we're not going to improve either, right? So there is a little bit of encountered incentives right now. But I want to encourage you to take a first step and open up a little bit so you can actually then see what's beneficial to everybody, or at least have this conversation, right? At least have this conversation. And of course, the customer, some of the data, and I heard it in another panel, it was really good. manufacturing companies usually don't make money on data. But why isn't there a chance for us to sell some of that data, potentially even to our customers? They might be interested in how this part was produced or what's specifically inside that part, right? So that can be interesting for them as well, and we can sell it to them. Good. And ultimately, I love memes, so I want to end up with this meme. So at the end, when we lay the strategy out, of course, it's a straight line, right? We want to do this now. We implement a bunch of technology, and then we're fully autonomous. Well, turns out it's not really the case. So I want to walk you through my last 7 years that I have lived, right? So you get it. You get some vendors coming to your place. You get some interesting technology. Might it be some cobots, some VR glasses, you name it. Everybody of you has it, right? AMRs, yeah, many AMRs I've seen there in the corner doing this thing, right? So this is, at the beginning, we got excited about the technology, right? But it was a pitfall because at the end, it was not the real value, right? Then we actually went back and did some maturity assessment, which I hope most of you did back then, 4 to 6 years ago. With some of the companies, most of the big companies offer maturity assessments, and then add on with some training and actually lay out some strategy for your company specific. And what really got us over this little ridge there was we built the Smart Factory Playbook, which I'm proud to be part of the ones that came up with it. So we during COVID, we had what we called the Smart Start Playbook or Smart Health Playbook. And we took that analogy, and a year later, we made the Smart Factory Playbook, and we laid out most of the definitions, what Smart Factory meant for us. And that went into all the divisions, and it was really well seen. So there is a second version out now. Yes, and that got us over the ridge, over this valley. And of course, we are now receiving this huge storm. The storm comes. The IT comes. So, of course, there was this huge pushback, right? So all of a sudden, IT comes. And I can tell you, if you're not prepared for that, they will kill this initiative. They have the power. They are sponsored by finance. You said 60%, right? They can limit your spending. And it's not that I want to talk bad about them. They're extremely well. We have integrated them now. It's just that there is this natural language disconnect between the two worlds. And so be prepared for that pushback. And I can tell you the reference architecture that HiveMQ shows will bring you to this common ground where they say, okay, we get it. We can somehow separate it. We're not going to be completely infiltrated and full with viruses after a month. And you will be to the right side where you then can build use cases on top of that UNS and hopefully get to that adoption. Because after the first use cases, you will also see that now you've gone through all the departments where you have extremely innovative people, where you have extremely open managers, and now you've exhausted all these people, and now you get to go through the early maturity, which has a completely different mindset about technology. So you're going to go down again, and then you're going to climb out with this adoption of the most successful use cases and the most valuable things that you have built over the last 2 to 3 years with this roadmap. And that's it. That's the journey. That's at least what I've said. And I came up with this little thing while doing this presentation. I call it collect to predict and share to improve. I encourage you to share, because if you keep it all by yourself, it's not going to do the value that you can get. Thank you.